The next program is determine digital output for a given ADC input using internal ADC of ARM controller. Okay, so this is the program. First I'll comment this because this is not the instruction, this is the heading for that program. Okay, now to remove this. Yes. Okay, so I'll save this program and I'll start explaining. I'll save this program as ADC.C. I'll add this program ADC.C. Here we can see there is one error, that is lcd.h, because I want this header file that is not there in the source group. So I should add the one LCD program which is not written by me. So the general program is there, that LCD program I should add. Okay, so I'll add that LCD.C. So now I have added lcd.c program which is available. Okay, so now there is no any problem in the program. We wanted lcd.h because I am not going to write any program for LCD, but I am going to use the LCD program, LCD subroutine for displaying the values. So in this program we are only checking what is the ADC input, and depending on that we are going to change the digital value. Analog input I will convert into digital. The digital value will display. Now so here we are taking one variable, that is ADC value is equal to 0 and buffer is 2 buffer is taken. Now what is the use of this to variable, we'll see later. Before that we have all the bit general purpose input output ports. Now the same general purpose input output port is used for multi-purpose. So we'll see that. Okay, yeah, we have here pin select, sorry, we have here pin select register. So pin select register, like pin select 0, this function select the register 0, and for read or write operation the reset value is always 0. Like that, pin select 1 for register bank, register 1, and pin select 2 for register 2. Now what function we want to do with that pins, like out of 4 different function, which function we want to use, so that we can specify by sending the 2-bit value. Okay, so 0 0 0 1 1 0 and 1 1. If 0 0, then it is a primary general input output operation. If 0 1, then bit alternative function, and 1 0 is second alternative function, and 1 1 is a reserved. I mean, if there is a third any alternative function is there, then that will be used. Now first we'll see what is where that our ADC is connected. ADC is connected to port 0 28 pin number, and one more ADC is connected to port 0 29. Okay, So 2 ADC we are using in our kit. So P028 and P029. So P028 and P029, I want to, that 2 pins I want to use it as a ADC operation. So here pin select the 2. Pin select 2 means uh, the pin select 2 is for P0. I'll show it once again. Yeah. P028 and P029. Now port 0 and port 1, only 2 ports are there. Port 0 is 28 32 bit and port 1 is also 32 bit. Now port 0 32 bits. Out of 32 bits, first 16 bit is operation function will be selected by pin select 1, sorry, pin select 0, and second 16 bit operation will be selected by pin select 1. Okay, like that. Port 1 only 16 bit higher 16 bit I can use, that is selected by pin select 2. So out of 4 function I want to select which function I want to do. Okay, so pin select, this is for pin select 0. For pin select 0, if I want to use pin select 0.0 as pin select 0.0 as a general purpose, then these 2 bits will be 0 0. If it is for transmit and receive, then this should be 0 1. Okay, like that. If this bit is for PWM, then this bit should be 10. Okay, so we have to load that particular value into that register. Okay, that is what the pin select is used to select the functions. Now our pins, that is P028 and P029, this is not there in the pin select 0, it is there in the pin select 1. Okay, because from pin select 0 we have only P0.0 to P0.15. So next P016, P017, P018, like that, P031 till that is there in the pin select 1. So pin select 1 we should use, and in that pin number 28, yeah, pin number 28 and pin number port number P028 and P029, I should use it as a ADC operation. Okay, so there is a list of operation here function values what we have to store for P0, like to tell which port it is and what function we are doing with that port. Okay, the pin select 1, this is starting from P016 to P031 as I told earlier. Now what we want is P028 and P029. So this pin I want to use it as a ADC pin. So I should load the value 0 1 0 1 to the bits of this P028 and P029. P028 bit is this one. So 0 1 to these 2 bit and 0 1 to these 2 bit to use that ADC. Okay. Now, so I here in this in my program I have copied, I have loaded P0 sorry, pin select 1, that is 0 1. Okay. Next ADC 0 CR, this is the register we are using for loading the value. Okay. Next initialize LCD, that is okay. if uh, the analog to digital conversion is started. We want to check whether it is started or not. For that, we are using this AD0. I mean, out of these two, out of two ADC, I am using ADC 0. So ADC 0 counter register, that resistor value, I'll check the MSB bit if whether it is 1. It means it is start analog to digital conversion. When it is done analog to digital conversion, we are like until ADC value is 80000. Okay, so it will be doing this operation, that is copying whatever there in the ADC 0 GDR. This is the resistor we are using in the analog to digital conversion. There is a inbuilt resistor. It will convert the analog signal value into the digital and copy that into ADC value register. Now in the ADC value register we have the digital value, but this digital value I have to normalize so that if I want to display in my LCD display. Okay, so I'll normalize by means this is like 6-bit simply shifted left. So I'll I mean it is a 10-bit analog to digital conversion is a 10-bit register. So I'll get the value, the 10-bit value, but what I want to display is only 8-bit value. So what I'll do is the lower 3 bits value I'll lower 3 bits value I will neglect. So for that I'll shift this ADC value shifting right side. Next, next this ADC value I'll using a sprint instruction, and I'll copy that into buffer register. Same thing is going to same like what ADC value I am getting in the digital converted value, that I'll copy save with the buffer. Okay. Now here we have 3 instructions, that is LCD put string. It is not an instruction, actually it is subroutine. LCD put string 16, LCD go to XY, and LCD put string buffer. So this is to display whatever value is there in the when we are putting into the function. So these 3 instruction, it is to display in the LCD. So our main program is to convert, our main program is to convert analog to digital. That will be done internally by the ARM processor. So how we are checking that it is converting? First we are initializing that we are using it as a ADC. Then we are starting the ADC, okay, by giving this value. Then we are keep checking whether it is finished completing the analog to digital conversion. When it is finished analog to digital conversion, this will come out of the do while loop, and it will copy into the buffer, and whatever there in the buffer it is going to display in the LCD. So how it is displaying we'll see in the Proteus. First I'll create a hex file for this. Okay. Yeah, hex file is created. Next, this is the circuit inside the kit. So we can see the LCD. the LCD is connected according to the which is given in the connection. Yeah, LCD is connected according to the pin number is given here. These are the pin numbers like P03 to P0, P02, P015. So these are the pin numbers of LCD. LCD pin is connected to the ARM kit. Okay, so same way is connected. Same way it is connected here in the Proteus. Okay. Now, what we want to give is a ADC input. As I told, ADC input is given to the pin number. Okay. ADC input is given to the pin number P0.28. P0.28 is ADC 0.1. Okay. So this is the second operation. The first operation is general operation. Second is ADC operation. Like that. Okay. So the second operation we are using. Now here I am giving a analog input by using a potentiometer. So how it is given? So potentiometer is, I'm going to keep this little up so that I can show the now here this um, potentiometer I can vary the value. It's a variable potentiometer. Okay. Now the program I have already created the hex file. That hex file I load into my circuit. The hex file is part B. Okay. In this case I have changed the hex file. Project I have changed. Next I load the, I'll start running that program. So when I'm running this program, it is going to display ADC value is equal to 604 something. Okay. But if I change the potentiometer value, so I'll change the direction. Okay. If I'm reduce this, the voltage is reduced, so ADC value it is also reduced. If I make it almost 0, make it 0, yeah. So now it is 0, so ADC value is 0. When it is full, the ADC value should be 1024. See that? So I can vary this potentiometer value. Okay. So as I am changing the voltage, as I am changing actually potentiometer, by changing the potentiometer actually I am changing the voltage. When I am changing the voltage, the equivalent digital value it is going to show. Okay. So for my program now, if I give 3.3 volt, it is 1024. If I give 0 volt, then it is 0 volt. So the program is working proper. Okay. So we can see here in the LCD, it is going to display LCD val is equal to 00. That is initially. Next, this buffer value means the buffer value is ADC value. So this ADC value I am going to display. Okay. So directly what I am getting here, it is a digital value, the digital value, but it is there starting from bit 6 to 15. Okay. So 10 bit value is there in bits 6 to 15, but I want to make it like a, it should start from bit 0. That's why I'm shifting it to right for 6 bit. Okay. and upper value, if there is any value, I'll delete that. So I'll explain once again. Here the pin select 1, we are sending 0 1 0 1 0 0 0 0 0. That is because I want to use P028 and P029 for ADC operation, not for general purpose input output operation. Next, ADOCR. ADOCR, I'll show the pin diagram. P028 and 29, and here AD0CR, ADO, AD0CR and AD1CR, that is a two different resistor for control the analog to digital conversion. So it is a 32-bit resistor used. User must write control word into this, okay, and function it will start depending on that. Like here I want to start the uh, analog to digital conversion. For that I am loading here, you can see, yeah, I am loading uh, 00200 D02. If I do this, it will start the uh, analog to digital conversion. Okay, first I'll set it for an analog to digital. I mean, what type of operation I want, like uh, it, yeah, whether I want a power down or edge triggered, so to start it, and end of conversion, what happened, what should happen, all this controlling operation is controlled by this resistor. Now once the register is controlled like that, then we are checking until it start analog to digital conversion. When analog to I mean that bit is 1, means it is doing that analog to digital conversion. So every time when it is changing the value, I want to update it. So we are checking the register. If the register value is uh, ADC value, if it is greater than I mean we the MSB bit, if it is 1, then uh, we should stop it. Okay, so uh, if we are keeping on updating the value what we are getting analog to digital converted value. So what I showed in the Proteus, it is we are, by changing the voltage, we are analog digital value what we am getting, that is there in this resistor. Okay, so that resistor value I am directly copying into ADC value register. If the MSB bit is 1, that means uh, it is read 1 data. Okay, one conversion is done. So if one conversion is done, then the value what is there in that variable ADC value is not actually direct digital value. So digital value is what we want to concentrate only is the bit 6 to bit 15. So only the 10 bit we want to concentrate. So what we are doing is remaining bits we are eliminating by shifting it to left 6 bit and ending with 0 3 FF. Okay, so the next 3 instruction is only to print that on LCD. So I'll show that Proteus window once again, so that you can understand how the output, okay, we're getting the output. Okay, so if we are for this program, if I change, sorry, yeah, for this program, if I change analog voltage, so if I change the voltage, it should change the digital value. It is changing the digital value. Okay, so this is about analog to digital conversion. Thank you. Okay, now we'll try this program in the kit. For that we have to open the flash magic and select the device. Device is LPC2148. Yeah. Then the next step is comfort. So we should find out where the or I mean for which comfort or kit is connected. So we should go for the device manager. Here we have to find out which is the comfort is used by the kit. So we have to put that comfort here. Next, baud rate is 9600 and frequency is 12 megahertz. It is block used by hex file, and next is browse the hex file. Uh, okay, so after browsing the hex file, we have to upload this hex file into the kit. So click on start button until it is loading the file into the kit. Once it is loaded file into the kit, we will come to know that it will show it is finished. Okay, yeah. Now it is uploading. Okay, now we can see it is showing the value. So ADC, we are changing the input voltage by varying the potentiometer. When I'm changing the potentiometer, the value analog to digital value is changing. You can see the brightness is there. Yeah, the ADC value 270, 150, 40, 2 means when you are varying, it is when you are varying the voltage, it is varying the digital value of equivalent to analog signal.